guys, welcome to Module 4 on integer operations. Right now, pause the video. Make sure you've got your notebook and your writing utensil ready to go. Remember, it's super important that you're taking good notes and learning good note-taking skills. That's the way you're going to learn the content in this class, plus you can use the notes on your quizzes. Today we're going to be talking about integer operations, so that includes adding, subtracting, multiplying, and dividing positive and negative whole numbers, and then we're going to throw some word problems in there as well. So you're going to start a new topic in your notebook. You're going to want to write down integer addition. And then you're going to want to write these things down, and you can abbreviate a little bit. You don't have to write the words like if, the. So if you want to write the signs are the same, add and keep the sign. Signs are different, subtract and keep the signs of the larger number. You don't need to write this down unless this is an error that you make. Two negatives do not make a positive. Those are the rules for multiplication and division. That does not work for addition and subtraction. You want to think of positive numbers like earning money and negative numbers like spending money. So if you spend $3 here and spend $5 more here, then you did not earn $8, you spent a total of $8. So the signs were the same, we add and we keep the sign. If the signs are different, we have a positive 4 and a negative 4. If you think of this like earning $4 and spending $4, you don't have $8. The signs were different, so you were supposed to subtract. And we don't need to worry about keeping the sign of the larger number. 0 is just 0. There's no positive 0, no negative 0. The positive and the negative are the same. You pause the video and use these rules to try these on your own without a calculator. For the first one, you should have noticed that the signs were different. This is like you've earned $4 and spent $3. So that means you're going to subtract and keep the sign of the larger number, so that should be a positive 1. For this one, you're spending $1 and spending $5 more, so you spent a total of $6 and you keep the sign the same. Okay, new topic. You're going to want to write down integer subtraction and underline it so that you can find it later. I want you to write down that instead of subtracting, we're going to add the opposite. Some of you have learned this as keep, change, change. This means we keep the first integer the same, change the subtraction to addition, and change the sign of the second number. Keep, change, change doesn't work if you don't know what these things mean. So make sure you write those down if you don't know. Change the subtraction to addition, change the sign of the second number. Now we just have to follow the rules for addition if we can do it that way. So I'm subtracting with positive and negative whole numbers. I'm going to keep the first sign the same. I'm going to change the subtraction to addition, and I'm going to change the sign of the second number. Now I can see that the signs are the same, so I add and keep the sign. Here, keep, change, change. The signs are different, so I'm going to subtract, and I'm going to keep the sign of the larger number. For this one, it was like I spent $5 and spent $7 more. For this one, it was like I made $5 and spent $7. You pause the video and try this one on your own. You should have done keep, change, change. So you keep the first one the same, change the subtract to an add, change the 8 to a negative. Now you can see that the signs are different, so we subtract and keep the sign of the larger number. For this one, keep, change. The signs are the same, so we're going to add and keep the sign. You don't need a new title. We're still on the same topic of integer subtraction. All of these are the same steps here. So remember, instead of subtracting, we're adding the opposite. Some of you learned this as keep, change, change. So for this first one, we do keep, change, change. And I actually like showing it better on the problem itself, because keep, change, change is easier to see that both of those become positive. In any case, it becomes 9 here. For this one, we keep, change, change. Now we can see that the signs are different, so we subtract and we keep the sign of the larger number. You pause the video and try these two on your own. You should have done keep, change, change. We add the opposite. The signs are different, so we subtract and keep the sign of the larger number. Keep, change, change. 4 plus 2 becomes 6. Notice that on this one and this one, we never change the sign of that first number. That one always stays the same. That's what the keep means. All right, new topic. Let's combine these together. Addition and subtraction of integers. You don't need to write this information down. It's the same as if we were doing before. Instead of subtracting, we're going to add the opposite, and then we're going to use our rules for addition. My suggestion is to never try to do all these at once unless you're really good at mental math in your head. It just makes things more confusing. Let's start out just worrying about -7 minus 5. Keep, change, change. These signs are the same, so I'm going to add and keep the sign, and then I'm going to bring down the +4. Now it's keep, oh, I don't need to worry about it because it's subtraction, or excuse me, it's addition, not subtraction. So I use my rules for addition. If the signs are the same, I would add, but they're different, so I'm going to subtract and keep the sign of the larger number. For this one, again, I'm just going to do 2 at a time. Keep, change, change. Now I can see that the signs are different, so I subtract, I keep the sign of the larger number, I bring down the -1 because I haven't used that yet. Keep, change, change. Now my signs are the same, so I add and keep the sign. You pause the video and try this one on your own. You should have done these two first. Keep, change, change. Signs are the same, so you add and keep the sign. We bring down the +3. No need to do keep, change, change because that's an addition problem. I notice that the signs are different, so I subtract and I keep the sign of the larger number. New topic, solving word problems with integers. So write that down. We're going to be talking about some key words for your word problems. So for example, what we've got here is we've got a table. And often you guys will ask me, like, when am I ever going to use this? Well, you actually will use negative numbers, especially when it comes to temperature. Negative numbers mean that it's super cold outside. In some cases, it's below freezing if you're looking at degrees Celsius. In degrees Fahrenheit, it's always below freezing because 32 is freezing. For A, it says how much lower. So I want you to write yourself a little list off to the side here about code words. So in your notebook, we want to write down that how much lower indicates that you want to subtract there. You see how much lower, you want to subtract. So it says how much lower was the 6 a.m. temperature in Toronto than in Seattle. So we're looking at the difference between Toronto and Seattle. Oftentimes when we do word problems, we do the large number minus the smaller number. Notice that I have to put 2 negatives there. How much lower meant I needed to subtract, but Toronto also has a negative, so there has to be 2 negatives there. We do keep, change, change, and that becomes 66 degrees Fahrenheit lower. I don't need a sign on that. If I use the word lower, that tells me that it's lower. For B, by noon, the temperature in Toronto had risen. If you see the word risen, that means you're going to be adding there. So the temperature in Toronto was -25 and it had risen by 14 degrees. Now it says, what was the temperature there at noon? Well, no reason to do keep, change, change. It's already addition. The signs are different, so I subtract. That gives me 11 degrees, and I keep the sign of the larger number. This time I'm not finding the distance between two things. I'm actually finding the temperature itself, so I do need the negative on there. So it's -11 degrees Fahrenheit for that one. Make sure you've got your code words written down before we move on. All right, you pause the video and try this one now about green riding in a bike race. All right, so I want you to understand that above sea level and below sea level do not mean you're in the water. So let me give you a quick sketch. So if this is the ocean, and then here's the land, and then there's some mountains, and then there's a valley, and then the land again. This valley is below sea level, but that doesn't mean that it's full of water. This rise here keeps the water from flowing into the valley. So yes, this is water, but this you can be below sea level and also not underwater. So make sure you understand that. So for the first one, it says the top of a hill rises 422 feet above checkpoint 3. So we want to find checkpoint 3. And then above, here's something to add to your code words list. Usually above is going to mean add. I'm not going to say all the time you're going to add, but in this case it is. It says, what is the altitude at the top of the hill? So we are going to add 422 -175. The signs are different, so I'm going to subtract 422 minus 175. That gives me 247. And then let's see, the larger number was positive, so I keep it a positive, and that is going to be in feet. It says how much higher is checkpoint 4 than checkpoint 3. So if you haven't already written this down, I can't remember what it said on the previous slide, but how much higher, that means we want to subtract because it's a code word for finding the difference. We're finding the difference between checkpoint 4 and checkpoint 3. So let's see. Checkpoint 4 is negative 61. I'm finding the difference between negative 61 and negative 175. Remember, I need the minus because it's how much higher, and I need the minus here because of the 175. We do keep, change, change. Now I can see that the signs are different, so I'm actually going to subtract 175 minus 61. That's going to give me 114. The larger number is positive, so I just keep this a positive. It's 114 feet higher. All right, new topic. Computing the distance between two integers. You don't actually have to say on a number line. When you're asked to find the distance between two things, the word between is telling you to subtract. So there's a code word you might want to add to your list. The word between is telling you to subtract. But distance is always positive. You would never say I walked 2 miles to the store and negative 2 miles home. So if I want to find the distance between A and B, one way to do that is just to count it. But that's a good way to make errors because I often have people say that the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces here. If I want to find the distance between two numbers, I'm going to subtract big minus small. Keep, change, change. It actually is 13 because you don't count this first dot. If I was counting my number of steps from my seat to the wall, I wouldn't start counting at my seat. I would count after I took the first step. So it would be 1, 2, 3, and so on, which is why this becomes 13. You pause the video and try this on your own. See if you can do it without counting your spaces. You should have done big minus small. Notice that you need a minus to find the difference between them, and you need a negative on the 10. Keep, change, change. The signs are different, so you subtract, and you keep the sign of the larger number. Remember, the distance between two things is always positive. All right, new topic, integer multiplication and division. Please write this at the top of your next section and underline it. You don't necessarily need to write this first step down. To multiply or divide integers, you just multiply or divide to find the number. Hopefully you already knew that. But this one I would write. This is different than for addition and subtraction, remember. If the signs are the same, the answer is positive. So two negatives do make a positive here, but only for multiplication and division. A negative times a negative is equal to a positive. A negative divided by a negative is equal to a positive. If they are different, the answer is negative. So a negative times a positive is a negative. A negative divided by a positive is a negative. Whoops. So let's evaluate the following. We just multiply like normal. 4 times 5 is 20, so it's positive. For this one, we're just dividing like normal. 48 divided by 8 is 6. The signs are different, so it's negative. Notice I didn't ask you anything about the larger number. I don't care about the larger number. I only care about whether the signs are the same or different. Use those rules and try these on your own. See if you can do them without a calculator. 18 divided by 2 is 9. The signs are different, so you should have said that was negative 9. Notice our larger number is positive. We don't care about that. That's only for addition and subtraction. You have to keep your rules for addition and subtraction totally separate from your rules for multiplication and division. They are not the same thing. For this one, 9 times 5 is 45. The signs are the same, so it's positive. Again, we don't care about the larger number because if the signs are the same, it's always positive. Make sure you have all this written down before we move on to the next slide. All right, same topic as before, multiplication or division, but now let's try to do a string of them. And remember, we don't necessarily need to do these all at once. We can do them 2 at a time if you want to. Negative 2 times negative 1 is positive 2, and I'm going to bring down the rest of the stuff I haven't used. 2 times negative 5, the signs are different, so that's negative 10, and I'm going to bring down the 3. Negative 10 times positive 3 is negative 30 because the signs are different. Notice you never heard me mention which one was larger. We only care about whether the signs are the same or different. Notice that I'm creating kind of this neat triangular shape. That's going to be important when we do order of operations later on. For this one, 5 times -1 is -5. I bring down the -2 and the -2 that I haven't used. -5 times -2 is +10. I bring down the -2 that I haven't used. The signs are different, so it's -20. You pause the video and try this one on your own. -1 times 4 should have become -4. You should have brought down the two -2's that you haven't used. -4 times -2 is +8 because the signs are the same. We bring down the -2 we haven't used. The signs are different, so when we multiply, it becomes -16. All right, let's look at some word problems. So you should be expecting to add some code words to your list here. So I want you to note that a change can either be an increase or a decrease. It might go up or down. If it goes up, that indicates a positive number. If it goes down, that uses a negative number. So a tram is moving downward 72 meters in 8 seconds at a constant rate. So what's happening is this tram is moving down, and in that time of 8 seconds, it goes 72 meters. But it takes 8 seconds to do that. So we're dividing this up into 8 sections. Each one is 1 second. What I want to find out is how much is each one of these seconds. What I'm actually doing is finding a rate, which means I'm dividing. So I want to divide 72 divided by 8, but it's moving downwards, so it's -72 divided by 8. Backwards, so I don't need that to be a -8 seconds, but I am moving downwards, so it's 72 meters. 72 divided by 8 is 9. The signs are different, so it's negative, so you should say -9 meters for that. In a lab, a substance was heated by 6 degrees for each hour for 24 hours. So this time we're not dividing because it's being heated by 6 degrees every hour for 24 hours over and over and over. This time I'm multiplying. It's increasing, so it's a +6 degrees every hour. So I'm just doing +6 times +24. So it's 6 times 24, and that should be +144 degrees Celsius. You might want to make sure that you've written increase and decrease down in your code words. Increase is a positive, decrease is a negative. You pause the video and try this one on your own. Same type of problem. We start with the tram again, but this time the tram is moving upward 9 meters per second for 45 seconds. What was the total change in the tram's elevation? So it doesn't give me the whole amount. What's happening is it's moving up for a whole 45 seconds, and I'm splitting up each one of those. Each one of those is 9 meters. So to figure out how many are here, I need to multiply 45 times 9. It's moving upward, so it's +9 times +45. 9 times 45 becomes 405 meters. So you should have said +405 meters. In a lab, a substance was cooled by 12 degrees Celsius, so the temperature is decreasing. It decreases by 12 degrees Celsius over a period of 3 hours. So 1, 2, and 3. 1 hour, this is 1 hour, this is 1 hour. What was the change in temperature each hour? Because I want to find the temperature in each one of these sections, I need to divide. But it's cooling, so it's -12 divided by 3, which gives me -4 degrees Celsius. You're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 4 in ALEKS. You should now complete the Module 4 practice problems in ALEKS using your notes to help you. Don't forget that if you need help in ALEKS, there's always a button for the explanation, and you can ask why for more information. When you're done, you're going to want to go back to your home page, click the circle with the 3 lines, click on assignment, and take quiz 4. That's it for today. You guys have a great day.